I gave an AI agent access to a real crypto wallet, real money on chain, no training wheels. And here's the thing nobody tells you: teaching it to move money took an afternoon. That part is basically solved. There are four dependencies and a tutorial. Deciding what it's allowed to do with that money, that was the entire job. That's where all the real time went. So, this is the stack I ship with: four layers, one for each thing an agent needs to touch money, and what each one actually buys you once there's a balance on the line. The thread running through all four is the same single word: give an agent money, and you need exactly four things: a brain, the loop that decides what to do; tools, how it reaches the outside world; a wallet, where the money actually lives; and payments, how it pays for things on its own. Brain, tools, wallet, payments. Every AI agent with a wallet project is some version of these four boxes. I've built this. And at every single one of these layers, the interesting decision turned out to be the same question: not what can it do, but what can't it do. Start with the brain, the loop that decides what to do next. I use Pi, and I picked it for what it deliberately doesn't do. It calls itself a minimal harness. Adapt it to your workflow, not the other way around. And that's the property I actually care about. I own the loop. I decide what goes into the context. I decide which tools exist on this turn. I decide where it stops. Three lines, and every one of those decisions is mine, sitting in my own code. But minimal doesn't mean empty, and this is the part that surprised me. Pi ships as a working agent. The hard machinery is already in there. Autocompaction. When the context fills up, it summarizes the old turns instead of falling over. Branch summarization: when you walk back through the conversation tree. Sessions that save to disk, resume, and fork, so an agent that stopped at 3 in the morning picks up exactly where it left off. You extend the whole thing in TypeScript, and it runs four ways: a terminal, JSON, RPC, or as an SDK you embed. That last one is mine. The agent is a component inside my service, not a thing my service lives inside. What it leaves out is the opinionated part: subagents, plan mode. It hands you the machinery and lets you build the shape. And when there's money at the end of that loop, the question you will be asked every time is, why did it do that? You want an answer you can read off your own code. Layer 2: tools, how the agent reaches the outside world. The fast way to do this is to give it one broad connection to a service and let it figure the rest out. That gets you running in minutes, and for a lot of work, it's the right call. With money in the account, the trade off changes. A broad surface means the set of things your agent could do is bigger than the set you've thought about. Not because the model is malicious, because you can't review a list you never wrote down. So mine are narrow on purpose. Every tool declares a validated input schema and a validated output schema, a hard 10-second timeout, and truncated returns so nothing floods the context. And red is separated from write. In the agent I'm running, there are 11 tools. 10 can only read. The agent cannot send a transaction. There's no tool for it. Not a rule in the prompt it might argue with. There's just no door. Layer 3, the wallet. And this is the one where I changed my mind. I started on Coinbase AgentKit. It is genuinely good software. The developer experience is clean, and on Base, your agent gets gasless USDC essentially out of the box. If you're building a Base native agent, that is a very strong default, and I'd point you straight at it. My constraint was just different. AgentKit's gas sponsorship covers Base mainnet and Base Sepolia. That's the design, not an oversight. Step off Base and the agent is holding native gas on every chain it touches. I needed it to work across chains. So the thing that made AgentKit excellent on Base was the thing that didn't fit me. That's a fit question, not a quality verdict. And picking the wrong fit is a normal, cheap mistake as long as you notice it early. So I moved to Safe, which isn't really a wallet. It's a control panel that happens to hold money. Three things it gave me. One, fees in stablecoins. Safe with the ERC4337 module plus a paymaster means the agent pays gas in USDC on any chain. Nobody's topping up native tokens on 6 networks. 2, multiple signers, which is the whole reason Safe exists. The agent is one signer, not the owner. 3, guardrails that live on chain. And that's worth its own minute. Because guardrails gets used to mean a paragraph in a system prompt, and that is not what this is. In Safe, a guard is a contract that runs before and after every single transaction the account executes, and it can revert, not persuade, revert. That's where policy actually lives. Spend caps, whitelist of addresses it may touch, time of day rules. There's an allowance module that lets a given signer spend up to a set amount per period and no more. And the pattern I'd point at: run a session key that authorizes the agent's routine work, and a spending limit hook underneath it that enforces a hard daily cap no matter what that session key approves. two independent layers, so a mistake in the top one is still bounded by the bottom one. The difference is where the rule lives. A prompt is a request, a guard is arithmetic, and now that money tool with no send function makes sense. It returns a signing link, a proposal with a 15-minute expiry that a human approves. The agent's most powerful action is asking, last layer, paying for things. X402. It's an HTTP status code turned into a payment protocol. 402, payment required, the one the web never used. Your agent hits an API, gets a 402, pays a fraction of a cent in stablecoins, gets its answer, no API keys, no sign up, no monthly plan. And this stopped being a toy. 165 million transactions, about $50 million in cumulative volume, roughly 69,000 active agents by late April, and AWS adopted it in May. But the part that actually points somewhere is Bazaar, a discovery index. The agent queries itself. It doesn't need me to hard code the service. It finds what's payable and pays, which, if you've been following the thread here, is also a control question. Now, the boundary isn't what I wired up, it's what I let it spend. Four layers and the same answer at everyone. The brain, a minimal harness, so I keep the loop. The tools, scope narrow, read separated from write. The wallet, on chain guards, stablecoin fees. The agent as one signer among several. The payments, a budget, not a blank check. Not one of those makes the agent more capable. Everyone makes it less able to surprise me. That's the inversion worth taking away. Capability is the commodity now. You can install it. It really is four dependencies and an afternoon. The scarce part, the part that's actually engineering, is the boundary. And notice none of these four are safety features bolted on at the end. Each one is the architecture. You don't add control to an agent later any more than you add a foundation to a house later. So giving an AI agent money turns out to be the easy half and the wrong half to be impressed by. The craft is in what you decide it can do. If you're building one of these, here's the thing you can do today. Open your agent and count the tools that can write. Just count them. Then for each one, say out loud what it can reach. If that list is longer than you expected, or you can't finish the sentence for one of them, that's your afternoon. Now, this is four layers I arrived at by shipping, which also means it's four layers I found by making the mistakes myself. So I'm genuinely asking, what's in your stack that isn't in mine, especially the wallet layer? If you've solved guardrails a different way, or you're using something I've never touched, put it in the comments. I read them, I'll go try the good ones, and if enough of you point at the same thing, that's the next thing I test on this channel. That control layer is what I've been building and what I'll keep testing here. Subscribe if that's your kind of thing.